Hi everyone, let's start solving today's LeetCode daily challenge question 319 bulb switcher. So let's try to understand the problem statement. There are n bulbs that are initially off. You first turn all the bulbs, then you turn off every second bulb. Okay. On the third round, you toggle every third bulb, turning on if it is off or turning off if it is on. Okay, so we are toggling every bulb. So for the ith round, you toggle every I bulb. For the nth round, you only toggle the last one. Return the number of bulbs that are on after n rounds. Okay, so we need to return total number of bulbs which are at on status after n iteration. Okay, so let's see an image explanation as well. So in this case, n is equal to 3. So initially there are three bulbs. So at round 1, we toggled every switch. Okay, and round 2 we toggled only the multiple of 2. Okay, and round 3 we toggled only the multiple of 3. So at the end, after 3 iterations, we got only one number of bulb which are in on status. Okay, so after understanding this problem statement and this image explanation, we're little bit going into in terms of factors. Correct. So we'll go step by step from let me take an n is equal to 1. So if I take an example of n is equal to 1, so for 1th bulb I can go to the first bulb to via first iteration only. So I can reach 1 and the answer of this particular n, the input number, is 1 only. Okay, let's take an n is equal to 2. Okay, so from 1 I can switch on the first bulb, and from first actually first is the factor of every number. So from first I can turn on every switch or every bulb. Okay, so for first, after first iteration, every bulb should be in on status, but after second iteration, uh, I cannot reach to like I cannot reach 1, so I will be turning off at the second status. Okay, so I will be turning off the second. So second switch turned on by first and turned off by second. So at the end we'll got only one bulb in the on status. Let me take an example of n is equal to 3. So first get turned on by 1. Second, in case of second, the first iteration turned on the second bulb, and in the second iteration turned off the second bulb. Okay, so this is the first bulb, this is the second bulb, this is the third bulb. Okay, now in the third iteration, so the first iteration turned on the third bulb, second iteration does not have any impact on the third bulb. Now the third iteration turned off it. Okay, so this problem statement also has an answer 1 only. N is equal to 2 also has an answer 1 only. Okay, let's take n is equal to 4. So first iteration turned on first or like every another bulb. Second iteration, first turned on. Okay, second turned off the second bulb. Okay, now third, this this is what I am representing, the ith bulb. Okay, now the third, so first iteration turned on, second iteration does nothing, third iteration turned it off, this was on and this was off. Okay, now in the fourth iteration, okay, this is regarding the fourth bulb. So first iteration turned it on, second iteration turned it off, second iteration turned it off because it is a like 4 is a multiple of 2 only. Okay, third iteration does not have any impact. Okay, now the fourth iteration can also reach to the fourth bulb, so turned it on. Okay, so the answer of this particular is, so the first bulb is on running status and the fourth bulb is on running status, so answer is equal to 2. Let me take n is equal to 5. Okay, first is first, second is first turned on, second turned off. For the third bulb, first turned it on, second does not have any impact. third turned it off. For fourth, first turned it on, second turned it off, second turned the fourth bulb off, third does not have any impact. Now the fourth bulb turned it on again. Okay, so till here the answer is 2 because of 1 and 2, and about 5. First turned it on, second does not have any impact, third does not have any impact, fourth does not have any impact, 5 turned it off. So first turned it on. At the end, the answer of 5 is only 2. Okay, let me take n is equal to 6. So first, okay, first bulb has turned on first iteration. Second, what about the second bulb? First turned it on, second turned it off. Third, first turned the third bulb on, second does not have any impact on the third bulb, third turned it off. Fourth, one, first turned it on, second turned it off, third does not have any impact, fourth turned it on again. Okay, till here the answer is 2. 5, first turned it on, second, third, fourth does not have any impact, fifth turned it off. Sixth, first turned it on, second turned it off, because 2 is a multiple of because 6 is a multiple of 2. Okay, now 3 turned it on again because 6 is a multiple of 3 as well. Okay, now on, off, on, off and on. Okay, so at the third iteration the sixth bulb is turned on, fourth does not have any impact, fifth does not have any impact, sixth have an impact, it will turn it off again. So the answer of 6 as well is here is 2. So let me give you an n is equal to 9 as well. Okay, so for n is equal to 9, okay, so first is first, 2 have an impact. Okay, so first iteration turned it on, second the same thing. Okay, 2 turned it off. For the 3 it is same, first turned it on, second turned it off, second does not have any impact, third turned it off. Fourth, first turned it on, second turned it off, third iteration does not have an impact, fourth iteration turned it off again. Okay, on again, sorry. So on, off and on. First iteration turned the fifth bulb on, second, third and fourth does not have an impact, fifth turned it off. Sixth, first turned it on, second turned it off, third iteration toggled it and switched to on, fourth does not have an impact, fifth does not have an impact, sixth turned it off. Okay, off. Now I will give you seventh. So as 7 is a prime number, so it can reach via 1 and 7 only. So 2, 3, 4, 5, 6 does not have any impact, 7 turned it off. Okay, now 8, first iteration does not have an impact and turned it on, second turned it off, third, fourth turned it on, this is on, this is off, does not have any impact, fifth does not have an impact, 6 and 7 also does not have an impact, 8 comes to off. Now we'll come to ninth. Why I taken 9? Because it will show you one more observation. So first turned it on, second does not have an impact, 3 turned it off, fourth, fifth, sixth, seventh, 8 cannot reach 9 because 9 is not a multiple of 4, 5, 6, 7, 8, and via 9 I can reach again and turn it on. So for 9 the answer is 3. Now the observation from 1 to 9, what I can see, where the multiples of n is an even number, in that case I can turn off the bulb again and again, okay, by toggling it. But in case of 1 to 5 and in case of 9, we see the number of perfect square comes into picture. The perfect square cannot be turned off at the final nth iteration, it will be in on status. So the reason behind that, so as we took an example of 4, So first was on status, okay, and fourth was on status, okay, because 1 can reach via 1 only and 4 can reach via 1, 2 and 4 iteration. So as I am seeing, where the factors are in odd number, okay, or the reachable thing is an odd number, so this is odd and this is also odd. At that case, the answer is, we can increment at that time the answer, okay. So that particular bulb must be in on status, okay, because the first is turning it on, second turned it off and fourth turned it on again, okay. Now in case of 6, a 6 can be reached via 1, 2, 3 and 6. So as you can see, these are even number of factors. In this case, it cannot be at the final iteration, it cannot be on the on status, it will be on the off status only. So what we need to do, from 1 to n, we need to find the number of perfect squares from 1 to 9, okay. So how many perfect square can exist in from 1 to 9? That is nothing but the square root of 9 only, okay. So 1 to 4, how many perfect square can exist? Okay, so 1 only and 4 only, because 4, how 4 is a perfect square? Because 2 into 2, okay. And if I see 9, so from 1 to 9, how many perfect squares are there? 1 is a perfect square, 4 is also a perfect square, 9 is also a perfect square, so the answer is 3, okay. This is what I am trying to say. So in this way, if the question asked in this manner, like find out all the bulbs which are in the on status, not the count of it, so you can easily find the bulb as well which are in the on status. So from 1 to nth, from 1 to n, we need to find number of perfect square exist, okay. So that let me give you the code snippet as well. So that's it. This is the answer of this particular problem statement. We are just finding out the math square root of n, and we are just returning it. That's it. So if this video helped you, you can like this video and subscribe to my channel and share this. Thank you so much.